live.
You good?
Oh!
Hey, the internet.
Mom, I'm famous. Oh wait, that's
We're live.
We're live. We're famous. We're vloggers now.
wow. This is quite the angle. I'm gonna ruin this. For the love of God. Hello. Alright. We're going to try to get started because we do actually have a time constraint, but definitely pick up your conversations during the demo, on Slack, email them, something else, send them a note in class, whatever floats your boat. Alright, so if you want to recap on what we learned today, after meeting is over, we're actually streaming this. We have a YouTube channel, so you can check out the VOD, or if you are sick of my voice but you want the content, we're going to post the slides on our website, so you can check those out as well. So, today we're talking about privacy and communications. Now that net neutrality is you can thank Sean for that one. So please, again, I'm going to keep saying this. If you have questions throughout the presentation, I'll be flying through, but if you raise your hand or send a message, I'll stop and try to address it. And if I don't know, I'll definitely point you to somebody that can. So let's get into it. So why does privacy, why does communicating securely even matter to us? Well, there's a handful of reasons. Information, it can be taken out of context. You see all the time all the fake news or just normal news or really anything. People, like a Snapchat even, someone will get the 2-second clip of you saying something out of context that you really didn't want to be taken out of context. So if you have communications that anybody can look at, they can pull out pieces of that and portray you in a poor light. You can also privacy. There's a lot of places in the world. We fortunately have a pretty loose policy on. Well, we have free speech here. A lot of places don't have that, and if their government can see their communications, they can censor what they don't want to be seen. Yes, question.
But what if I have nothing to hide?
What if you have nothing to hide? I mean, paint it on your shirt, run around. I don't care. But if you want to, these are some tools. And some techniques that you can use to perform communication securely. So I kind of covered this already. And then again, just kind of to reiterate, confidentiality. So if you secure communications between friends is all fine and great, but if you're the government or a large corporation and you need to, send your latest prototype somewhere, you don't want anybody to be able to just take that, right? So you need that confidentiality. Sometimes you need anonymity. Like I was saying before, there's some sort of repression that you need to circumvent, be that some sort of uprising or even journalism. So if you're trying to go do some sort of exposure, some piece on some other part of the world that may not have the kind of free speech that we do here in America, that can be helpful for you. And then finally, as is the case with pretty much every topic within security, you can't always, or these tools can be used for good and bad. So you can do some things like data exfiltration. So if there's some piece of malware that gets into your network, what's up? This doesn't look good.
All right, we're gonna move upstairs
because
apparently this room isn't reserved, even though I reserved it for every single week, minus Schmookon week. Oh, sorry, ASAP week. So if you guys want to pack up, you can move upstairs to the second lab.
Why?
Long live the tradition.
Liz just came in
and told me that this room was reserved.
Who's it reserved for?
I'm not sure.
Squatters' rights! Oh my god. Jesus.
Sounds like, yeah, alright, keep going. This happened in classic, alright. The reason I'm not talking in languages, but this is classic.
Wow. What a time to be alive. I forgot about those slides. I forgot about these two slides. Those two I just talked about. I forgot they were in there. Yeah.
Am I just unplugging stuff? Or what's going on?
I'll plug it.
Wow, I'm glad we're all gonna fit in this next room.
I'm leaving the dongle in my computer.
That's fine. The other thing's just in my pocket.
Thanks, bud. Yep.
Yeah, it was.
How's that camera?
Where's the HDMI cable? Right here? Okay, plug this in.
Fuck.
And then give me that one. Yeah.
I'm going for it. Is this right? Is that working?
No, but I mean, once you get those down, like,
Do your work.
it's just understanding like the way it works.
One moment, please. Step back. Guess we're going back to the Google form.
Oh shoot, we never.
Are we going? We're live. Oh, all right. We're live again. Pardon the interruption. The auditorium wasn't secure enough for this meeting. Came up here and opened the door. It's a lot better. All right. Are there any questions about this? Can I move on? Cool. So just a quick overview of a very selective history of cryptography, because without cryptography, it's hard to have secure communications. So let's start off by apparently the first known use of cryptography, and that's in quotes because it's a lot different from what we think of cryptography as now, was 1900 years before, or BCE. So what is that, 4,000 years ago? It's a really long time. Basically, it was special hieroglyphs in a tomb in Egypt that weren't part of the standard alphabet. Moving on, a little bit 800 years ago, the first frequency analysis techniques were invented. So that's a way of sort of cracking cryptography, so brute forcing. If you have simple ciphers, you can analyze them. If you know, so in a mono alphabetic cipher, it's like 1-to-1 basically between alphabets. So certain letters in certain languages are more common than others. So for example, in English, E is the most common letter. So if you know there's a letter that's occurring a lot in the ciphertext, you can say that's probably E and kind of work from there. So then another couple hundred years after that, the Veneer cipher was created, and that's polyalphabetic, English is hard, cipher, and that's using multiple alphabets, so it's more resistant to that frequency analysis that we were talking about before. And then finally, the 1940s, a huge jump is we're starting to get into mechanical and electro-mechanical, so think computers, types of cryptography, so the Enigma machine, if anyone's seen, Imitation Game, and to get stuff like that. So now jumping into a little bit more modern forms of cryptography, these are all kind of computer-based. They're bit-based as opposed to words. So in 53, we have the concept of hashing, one-way function kind of validation type stuff is termed at IBM. And then DES is in 75, and that's the kind of de facto symmetric encryption for some, I guess 20 years or so before it's eventually replaced, but we'll get there in a second. And so shortly after that, the concept of asymmetric encryption is kind of created by Whitfield Diffie and Martin Hellman. And basically this means that up until this point, you kind of had to have a shared secret to be able to decrypt the messages that you were trying to transmit. So if it's something as simple as a Caesar shift, both parties need to know what that shift number is. So say it's 13. Both parties need to know that you need to rotate the alphabet by 13 characters to get that message. So both parties need to know that. So in 76, we're starting to see the evolution of something where two parties can have, they only need to know something that they know, and it doesn't need to be, there is sharing that's involved, but they don't need to know the same thing. And this will be important, and we'll go into this a little bit more later. So then the 90s, the internet starts becoming an actual thing, it starts becoming commercial, and people are like, oh, we need security and secure communications that's going on. People are buying stuff, and we don't want anybody just to be able to be, oh, that's just imagine if you're watching network traffic and you're just looking at it and you're like, oh, that's a credit card. That's a credit card. We don't want that to happen. So we need to have some solutions to put in place to prevent that. And then finally, getting a more recent, last 10, 20 years or so, DES is replaced by AES, which is now the new de facto kind of symmetric encryption. So that's, remember again, the shared keys. And then 2008 is the most recent version of TLS, which is 1.2. This is the this is how your web communications are secured, and this is asymmetric and then goes to symmetric. Well, I'll talk about that later, and then again next week when we talk about web. And then finally 2014, I've got in here, this is when Signal was officially released. This is a, okay, Sean. This is a secure messaging platform, and the reason I have it on here is it's actually its own protocol, whereas all this other stuff is kind of just like AES and TLS kind of evolution of them. Signal is actually its own messaging protocol. So where do we see this? As I already mentioned, web, that's kind of what I focus on, so web, that's great. Email, you can do encrypted email. By default, it's not. It's just, you know, just text. But you can use something called Pgp, and you can encrypt that email. Messaging, there's everybody's messaging. Everyone in this room has either sent a text, sent an email, sent a message on Slack, sent a message on Facebook. You've probably done all of those things, actually. So they have secure communications built into those. And then you can also get security kind of lower down. So that's kind of application level security. And you can also have it more at the network level with VPNs. And then also you can use, I have SSH kind of as its own thing here. And that's, you can use that tool while it's, you know, for remote administration. You can actually leverage some of its features to kind of build yourself kind of a VPN of sorts with that tool itself. Oh, okay, yeah. RSA's origin story is pretty cool. Go check that out. Anyway, jumping into TLS. Yeah, so it's built to provide security and integrity between two parties talking. So in my previous example, if you go to Amazon and you want to buy one of these things, this clicker thing, you need to know that your information, your name, your shipping address, your credit card are all being sent to Amazon servers correctly. You want to make sure that they're not being modified at all, but you also want to make sure that nobody else can see them. So this is kind of where TLS comes into play. It starts out with a handshake, and it negotiates a shared session key. And this is something you'll see a lot. While we have symmetric and asymmetric encryption, symmetric is a lot faster compute-wise. So what we want to do is use asymmetric encryption to negotiate or send some sort of shared secret, and then use that shared secret that was sent securely with the asymmetric. So we get the best of both worlds. We get the asymmetricness and also the speed. So you negotiate a shared key with these various methods. You may recognize those names. And then the shared key is used to symmetrically encrypt the session. Just a note about FS, this is forward secrecy. And what this means is that they are cryptographic systems in which the session key, just a second, will not be compromised if one of the private keys is compromised in the future. So if you lose if one of the parties loses their keys, only messages in the future will be compromised. So it's kind of, we were testing out something called Riot Chat last semester. It's kind of a long story, but basically it used encryption in it, and so when we added new people to that chat, they couldn't see any of the messages we had sent before they joined. They could only see messages that were there after they had joined, and then we could all see those. And then finally, you can do something called key pinning, and what this is there's a certificate chain, which is kind of how you validate the public key of, it's the next slide, but it's also how you validate the public key of Amazon, say. So what that is it's basically saying this is a list of the keys that should be used with this site. So if you get one and that's not the one that you're supposed to be using, then it will be you won't continue that communication because something has gone wrong in the middle. So X509, this is a standard for certificates, and what these they are a format for public keys and public key infrastructure. So so they're composed of three main things: the public key, so Amazon's public key, the identity, so Amazon.com, some address in Washington, and then they're signed off by a certificate authority. And what that is that's we call it a trust anchor or a root CA, and that's basically some party that everybody trusts. And what that party does is we've all agreed that we're going to trust, this corporation. And what they do is they verify that Amazon is Amazon, and then they put that signature on this certificate, they sign that certificate saying like, I am. So if I have if Sean has a public key that he wants to give out to everybody, I look at it, I'm like, okay, this public key goes with Sean, that is Sean, I sign off that this is Sean's public key. So then everybody knows that if you trust me, you can trust Sean. All right. So now I'm going to kind of go over some examples. I've talked about this. Hopefully you can see this kind of. Basically, the idea is HTTP on its own is a text-based protocol up until HTTP 2.0. Again, next week we're doing web. So if you can, the monitors are in the way. But basically, down here you can see this is just a Wireshark capture. You can see if you capture just normal HTTP traffic, you can see the text, you can see the GET, you can see the cookies, you can see the user agent, you can see anything that the web server is going to see, you can see it. And then up here, we've done a web request with HTTPS, so using SSL, using TLS. And when you try to look at it, all you can see is a bunch of encrypted stuff, and you have no idea to know what that is. So now, probably the most two confusing acronyms in security. The good thing is if you mess it up, you're probably still right. But Pgp and Gpg, and what this is Pgp stands for pretty good privacy, and that's the protocol, and Gpg is the implementation, and it's called the GNU Privacy Guard. So Gpg is like the open source software that you use to perform PGP stuff. It's confusing, but it doesn't matter that much. Remember one of them and you'll get the other one. So it has a couple cool features. Again, it's a hybrid crypto system. And so the first thing it actually does is it compresses the data, because this is important for two reasons. When you do compression, compression takes advantage of patterns within your plaintext data. And one of the, as I talked about earlier, the ways to break cryptography is to analyze those patterns, frequency analysis type stuff. So if compression is done, it removes a lot of those patterns, and it makes it a lot harder to analyze. And then secondly, the kind of maybe more obvious reason for compression is it just saves space. So after it's compressed, it's encrypted with a session key, and this is pretty much random. It's generated by like your mouse and keyboard movements. So has anyone ever done the exact same pixel perfect mouse movement twice in a row?
3 times a day.
Okay. So that's how that's generated. And then that's encrypted with the recipient's public key. So this does require key sharing. I guess I should touch on briefly. So in a public-private key or asymmetric key encryption scheme, the keys can encrypt to each other. So you have one key that's a public key that you give to everybody, you don't care who has it. And then you have one key that's a private key that only you should know. And so if there's a piece of data and you encrypt it with your private key, everybody with your public key can decrypt it. And if you encrypt something with somebody else's public key, only they will be able to decrypt it with their private key. So you're sending the session key, so the symmetric key for decrypting the data that you want to send. You're encrypting that with whoever you're sending it to's public key. So this does require that you have each other's keys. Keys for PGP are stored in 2 key rings. This is basically just ways of separating public keys that you have and private keys that you have. And you can also do something called signing. So basically what this is it's a way to kind of validate something, like I was talking about with the certificates. So basically what it is, you encrypt the data with your private key, and then obviously this can only be decrypted with the matching public key. It's actually, you encrypt a hash with your private key, so you perform a hashing algorithm on whatever data you're sending, and then you encrypt that. And so when the data is received by the recipient, they also hash it, and then they decrypt the hash that you had with your public key. And if they match, they know the data hasn't changed. I already talked about certs. We've got another resource down here if you need to learn more, if I did a bad job, or didn't cover something. So, getting into Keybase. So this is really cool. And this is a platform for sharing, for proving identity and sharing identities. So what this basically says is I have an account on there. You can go on there and you can find me. And basically, my profile says, I'm Ohan, and these are some other accounts that I have. This is my Pgp key. This is my GitHub. So if you can see that, you can say like, and like here's a public key. So if you see that and you're like, oh yeah, that's a picture of Ohan. I saw him working on that project. That's probably actually him. So that's probably his public key. I can probably trust this. So they have this idea of identity proof. So like I said, that's an actual example. You can sign in with GitHub. You post a gist, and then Keybase will verify that that is actually you, and then you'll get a little check mark on your profile. Yeah. So if you go to this, all parts of the profile are verified by some other parts. When you create an account, you get a key, and then you register your laptop, and then that original account well, the first one's a little bit weird, but so say you register a device, and then you want to register your phone. You have to have both devices, and then you basically, the short version is you input a code when you say like, I want to use this phone, and it's like, well, do you have the other device? And then if you do, you enter the code on the other one, and then it's like, okay, so my laptop verified that actually is my phone. So you can see this web of trust, and you can actually go and check anybody's profile and see what they've added and what device like verified what, which is really cool. So in addition to this kind of identity proof and sharing platform, it actually has some other stuff built in. It has communications built in. So there's end-to-end encryption, not only in messaging, but also there's group chats and team chats. They just released a little over a month ago, which is really cool. eBoards actually just looked at it earlier this week, and we're testing it out. We think it's really great. And probably like low-key the coolest thing about this is they're sick of having to know someone's email or someone's name even. There's a lot of people, you see some influencers on the internet or a Twitter account or something, you're like, wow, that person's awesome, I want to talk to them. And you have no real information about them. You have some random Twitter handle, it's a bunch of hex digits. You're like, well, how am I supposed to figure out who this is? That's fine. On Keybase, you can search for them by their Twitter handle. That's one of the ways you can validate somebody. So you can search through a lot of different platforms, GitHub, Twitter, Reddit, Hacker News account for some reason. There's a couple other ones. So this is really cool. I highly recommend you check it out. And remember, this is like an identity platform, so this is one that you probably do want to use either your real name or like if you have some alias that you want to be, that's consistent across the entire internet, you would want to use this here. So this gets into Signal. As I said before, this is a secure messaging platform. They've actually developed sort of their own protocol that's been, it's all open source, and it's been federated by various organizations, and everybody agrees that this is pretty much the best right now. Yeah, and they also have end-to-end encryption everything, and you can do group chats and send files and stuff, and this is really helpful. And it's also, the protocol is so good that's also been picked up by all the other major chat platforms. So Google Allo has it, WhatsApp has it, and Facebook Messenger. In Allo and Messenger, it's an optional feature. In Allo, you have to enable incognito mode, and then it enables this protocol. And in Facebook, I think it's called secret messaging. It's something, it'll like turn the screen all black instead of like the nice blue. But you can turn it on if you so desire. And of course, all this stuff is free and open source. You can check it out. Has these various licenses, but you can definitely go check out the source code if you're curious about what's going on with that. All right, so Tor, it stands for the Onion Router, and that I'll leave to more of a networking course. You may talk about it. But the short version is that there's a network, and it's an anonymity network. And what happens is it's kind of like a fancy VPN, like with multiple hops, basically. So you're Alice, we are Alice. We want to go to Google. Well, this is a good example. We want to go post on Facebook, but we live in the Middle East, and they don't let us do that, and we don't want them to know that we're doing that. So we send our traffic through Tor. It jumps through some nodes, comes out of an exit node, and then from the exit node, our traffic then has to route all the way to Facebook. So Tor can be used for just normal web browsing. Like I said, you can go to Facebook on it, but it also has something called the dark web, or allows you to access hidden services. And this gets, at least in my opinion, a little bit of a negative connotation to it. Nothing about that is really illegal, but illegal stuff does happen there. So yes, you'll hear about, I think I saw this stat yesterday, 14% of identified hidden services are like for dealing drugs. But that's only 14%. That's not all that happens on there. So that's just something I wanted to note about that. And then finally, you can use it as a SOX proxy. So if you have some application that's like SOX aware, you can tell it to route through Tor. So it doesn't just have to be the Tor browser. So now the kind of more generic VPN, we're just going to talk about VPN. You can set up OpenVPN, which is a free open source one if you need to do this. And there's kind of two main use cases for VPN. Well, there's a couple, but two of the main ones are a remote employee. I'm sure everybody's heard of this. You want to work from home, you're sick, you're traveling or something, but you need to log in and get something at the office. Use a VPN, and it's like you're right there. So basically what a VPN is it's a extending a private network over a public network. So basically, once you're connected, all your traffic is tunneled, and it's like you're logically on the same subnet as you are, in the office. So you can be anywhere, and all of your traffic is encrypted back to the office, and then it's back in the network. So there's kind of two types of these. There's full tunnel and half open, and basically it's pretty self-explanatory. The full tunnel is every piece of traffic that you generate goes through the tunnel, and half open, only traffic that's destined for, hi Luke, that's destined for your corporate headquarters is going to go through the tunnel, and the rest of it's just going to go through, proceed as normal. So again, getting into the secure shell, there's actually ways to use this to kind of wrap its encryption around all the stuff that you may be wanting to do. So it has two forms of, well, I guess it actually is three, but it has two main forms of port forwarding, and basically what you can do is say, I want a port on my local machine to be forwarded to a port on the remote machine. And you can use this to tunnel traffic. So I've done this for web traffic. You can say, I want port 8080 on my local box to be forwarded to 80 on the remote box. And then you can set your web browser's proxy to localhost 8080, and then all of your traffic will get forwarded through the SSH tunnel, all encrypted, and then go on its merry way from wherever you're SSH into, which can be very helpful. SSH has also kind of been used to wrap itself around some other common tasks that we do. So file transfers are pretty important. You often will need to get files from one place to another. So you can use stuff like SCP and rsync to kind of, they take advantage of the SSH protocol, and also they share a very similar syntax. So if you want to move something from computer X to computer Y, you can be rsync file I want to move, and then you do like space and then username at Y : which will put you in your home directory, and then like file that I moved, and it'll just copy it all through there. You either can use your password, or if you have a key set up, in this case you use RSA keys, it will do that automatically for you, which is really, really helpful. Alright, where are we? So, as I said at the beginning, And this could be, for good use too, but all communications, and this is part of the reason why there's been some pushback by the government and various entities to, have more, what do they call it, Joel? Oh, he's asleep. I'm not asleep. Oh, no. Simon's asleep. What do they call it? More government-friendly crypto? What was it the other day?
Responsible.
Oh yeah, more responsible encryption, which is complete bullshit. That's not a thing. But if there's communications that are going on or data that's being pulled out of a network, they're like, well, but we're the good guys. Like, we should be able to look at that. But computers don't have a notion of good guys or bad guys. They're just a bunch. Yes, Joe.
What if you set the good bit in TCP? Then they'll know that it's good. And it'll be okay.
You should call up. Yeah, you should call up the FBI and tell them.
I'll do that.
All
We'll
right,
talk about that during the networking.
Yes.
Should I tell Jeet to just trust me on this?
No, don't talk to Ajit. All right. Basically, you can use encryption for good or for bad, and I'm not going to be up here and tell you for an hour that it's only used for good, because it's not. Just really quickly, I am out of time, and I think this is pretty much the last slide. There's also stuff that you can see, covert channels, so using non-standard methods of communication, and one of those, steganography, so like hiding data, so like often you'll see like data hidden within pictures or something like that. That's really cool, but check that out on your own because we've gone over.
I can do those too.
Caveats. Yeah, there's a lot of stuff. If you collect a lot of data, there's a lot you can find out without actually reading. You don't have to perform decryption to have a pretty good idea of what's going on. So just this quick example here, if someone knows, they have the metadata, they know that you called a phone sex line at 2 in the morning, and they know it was 15 minutes long, but they don't know what you said, they have a pretty good idea of what you were talking about. So that's just an example. Okay. So yeah, we talked about all this. Again, the slides will be available eventually. Are there any questions? Kind of blew through a lot of stuff. There was, yes.
How good's PGP?
Pretty good.
Oh, okay.
The site's not up. We're gonna make a Google form or something for the challenges.
It's already done.
Yeah. Check those out. We didn't pray hard enough. That's it. Have fun. Ask questions. Thanks.
Hey guys, just real quick, for the challenges, you will be sending proof for some of the challenges to an eBoard member to get the flags. So if you guys message or do something to us that sends something to us, just be patient. We will get to you as fast as possible, okay?
Yeah, something I want to mention. So this semester, we're
trying a lot of new things.
We're trying a lot of new stuff, especially because the end of this semester is culminated in IRSec for us. Next weekend is ISTS. It's too late to sign up for that.
But you can still sign up.
White team's still open, but to blue team, it's too late for you. But that's right now. IRSec's kind of the opposite. It's like the second to last week of the semester. And these are a lot more hands-on than the CTF, sort of. So we're going to try stuff a little bit different with the demos, a little bit more labby than challengey, if you will. So there'll be stuff where you have to configure something, or you have to do something, and you won't necessarily find the flag and like RC3, like this is the flag. You're gonna be like, send us a screenshot, and you'll be like, look, I set up XY service, and then we'll be like, okay, and then we'll give you a flag that's RC3. You did the thing. So just keep that in mind. You're not always just being able to, run the strings grep RC3 and get through this semester. No.
So to access all the demos, you can go to tinyurl.com/rc3 week 1, and you'll see it on there.
Or general.
Oh my god.
Or general. I didn't know you posted
general
in
in
there.
Slack, that's also
Yeah, or if you go to general and Slack, whichever one works. I don't know.
Oh god, I need one. Where did Yo.
You're always telling us how you basically live on Slack. I think we can handle
You want water? Can we get me one too?
Oh, like over there? Like fancy water?
Yeah, you want fancy water? I want fancy water.
Can I write like a little link up here for people to sign up for it?
Do that. Go ahead.
Where's the marker?
option right empty this, but to adding this together makes 100 kilobytes, and then it converts that to
Hey, Sean, you write the tiny URL is on the word.
Yeah. I'm trying to find a marker.
Oh, actually,
My laptop
I got it.
No I have one in my bag.
So week 1 with any slash or like RCS slash.
Alright. It looks like that. Okay, that's the URL. I'm sorry that we had technical difficulties and like room reservation difficulties. Please join the Slack. We'll keep you guys updated on all our progress and getting everything set. Yeah, that's all. There were some reservation issues. We got like overridden, but you know, whatever. Yeah, definitely do the demo. eBoard will be walking around helping you guys out, and also just feel free to talk to your neighbors and kind of just talk and see how they got into security. So yeah, that's it. Ask a lot of questions.
Where's that?
Just press enter.
On what?
It's another screen.
This one?
No, the laptop.
It figures like all the stuff up and running, and then the website for it. Doesn't that figure? There's no
How are you checking 120?
Then you'll take out our slow bit. It's not good, it's slow, but it works. So bro, challenge 1 is to do this. Easy 3 and easy 4 are the exact same.
Oh, this is a great picture. Alright,
If you want to know what Proxy is.
yeah, I'm just going to Andrew. They'll be on like the same location.
Make over more different idea, check every word. And then I build a string.
If it's really not Proxy.
Have you done like
Yeah, I've done my first 2 years.
yeah, it's an aggregation of CDI psychology. Sometimes it can be in person.
I did. Yeah. You are Aiden. Aiden. Yes, Aiden. You got it right.
Just your second semester.
Yes. How's it going?
No, I might.
But you should. I'll try. I'll put the dates on it too.
No, I'd be good for Christmas.
What's up? I want to see it. Ow.
Yeah, Simon, I made a secret challenge.
Who did?
We're like all ready to go. I just have to give you the flag.
Well, secret.
Because I don't want to tell someone to copy it. That's fine.
They're emailing you a Slack handle. Their Slack handle. Here, right here. They're offering one their Slack handle. Oh, they're trying to get me? Should I just flag on Slack then? Yes.
Oh, God, no.
I just saw why you want to yeah, how I saw it. I don't know. That's the first one I clicked. Oh, I see it. Yeah, I can see that. Oh, I know. No, you build a meme about the farmer. There's an interpreter.
I'm just looking forward to being like,
Yeah.
Yeah, there's absolutely no bearing.
one more weekend.
I
I'm already I'm noticing. I'm like, I have to apologize. I'm just.
When is CDC?
I just ball fighters.
This is a I might just
So there's a risk to keep it the alpha to wait. It's probably the thing we just so many a lot of this is garbage. Essentially, and then we'll just find a spot. Yeah, it's like they're literally that's probably where it's type that into grep. There you go. That's like the easiest way. I have to trade something else.
It's like a shirt pocket.
Alright. Just so you learn something. It's like camouflage, and I'm invaded this guy. Have you ever invaded with red dude comes in? This guy is trying to find me. He does not notice this.
Talk to Russ.
And then he starts going that way. And he goes this way. He's like trying to check the corner, right? And that would be hilarious. Where is memes from a book? This one's cheesy and hilarious too.
Made by a guy over there.
No, typically, it's like typically flags will have like RC3 dash something. But for show proof, it isn't have like where CTF will let you actually find it in text. It'll be like RC3 wait, you have a dash. They can see that driving through, and then all of a sudden, like,
I'm like walking up the cars and I just see like this rain goes like,
it's like, wait, I want to get away. So, why am I doing this one after
This is the one. Like it's all it's just something that happens.
I'll be back here a lot.
Oh wait, oh is this?
I'm in your team.
Flags are formatted like that. Yes. No, you're good. You're good. Like,
I just
yes.
don't
So
know what I do. Because all my duties right now, just tell me what to do.
Just like copy it.
Yes. So there's entry forms for each.
Is it just the brackets?
It's the whole thing. So that's the flags are formatted.
But not before next week.
This is all just.
I'll do whatever you want.
So
This will do this flag. What? It says RC3 is broken.
Yeah, let's think about it.
You have to get back to
what is
graduate in there. Is it is that a good flag? Like that was no. It's not even. I mean, it's just gonna be no one knows what they're doing, so I'm just gonna tell people what to do.
Yeah, that's how they're formatted. So whenever you find that, I'm terrified.
Like literally the last time I dropped, I don't because I swapped out of DSS. Graduate.
Yeah. Hey. Change it back to 411.9.
Give me any of the Linux stuff. Oh wait, I'll do the web one. Oh wait, remaining stuff. I'll do like IRC. I can do DNS in like 2 minutes. Are we using Ansible to do this?
No, we just.
I have Ansible to do half of that already.
We just started. We just got our groups on Wednesday. Yes.
Because ISPS made a lot of Ansible things, and now I have Ansible for all of this.
Yeah, we had an all Windows team and then now that you're here, and a bunch of stuff.
What? I can do whatever you want. So just let me know, but not this week. Cool. I know there's a lab due soon. I don't really know what that means. It's due next Sunday. Oh. Wow. I just want to let you know because I just got on a meeting today and they assigned me to a team. And I'm like, I don't know anyone that's taking this course, so it doesn't matter. He's like, okay, you're on team D. And I was like, alright, who's on it? He's like, Andrew. And I'm like, I don't know who that is.
Who's on our team?
Alright, if you want to join the RC3
which one?
team, send
Which
me
one?
your username like on Slack
Names of the faces.
or validate yourself somehow.
Or validate like your RC3 email on your secret.
Not John.
Yeah, or something. I need to know it's you.
I think I know who's that. Okay.
Someone has asked to join.
Most of our teams
Just so you guys know, each nominee
yeah, I know that. It's you and Matt.
where you go to enter the flag.
I was like, wow, I know most of those people.
Oh, okay.
Challenges are going to be open for the rest of the week, so if you guys want to keep doing these, don't worry about it. When our time slot ends, you can keep working them at home on your own computer for however long you want, and you can keep submitting them as well.
And we're literally like always on Slack, so you can bring
Yeah.
also,
First place last time, so top jar.
I kind of get the race.
Tell me about it. I know, so it's literally it's a little
Oh yeah, I know. I was in there. Literally, she just opens the door. She's like, "Hey, Kyle Corretto asked for a whiteboard to be delivered." I see two guys like holding it. I was like, "I don't know where Kyle is, but you can just put it in here." Then I understand how large this fucking whiteboard is. However big the club office is, it's basically that large. What is that for?
The office. What's the office? Yes.
Where is it gonna go?
On the wall. Which wall? The one that the desks are on there.
The one with the server racks on? Like
No, the other side. Opposite side. Left side. We're gonna have to move the desks around.
Where?
Like, there's desks here, and there's a server rack here. We're gonna swap them, and then this wall's like...
We're gonna have to do this at like 11 o'clock at night when nobody's here.
This is gonna be during ISTS weekend, probably. Like at the end, before we move the server rack.
So we're gonna have to use the hallway.
Well, the server racks are gonna be out, which is why we should do it then. No one's gonna want to do it then, but I'm gonna do it. It's gonna suck. Some major fucking dick. Trust me, I know, but it'll be worth it. I didn't expect it to be that big. I was like, hey, can we get a whiteboard? And this is like, how big? I was like, she pointed like the whiteboard on not this wall, but like on her wall. It's like this big. I was like, yeah, maybe a little wider. It's a little wider.
A little bit.
It's like, you know, 8 times
like
as wide.
this big.
It is actually like, I think, one of these.
Oh my god.
Oh, it's nuts. It's heavy, dude. That thing's like 20
Yeah,
pounds.
they literally have 2 people like carrying it.
It's so heavy. Oh, you graduated? I'll be back. Oh. Call me and ask questions.
Oh, for real? So they really did like a whole
And then afterwards,
Oh my god, what is this? Should be doing it, but I can't do it. I have to go to that office, and I don't think I want to do that. I haven't been outside in a while. But after next week, we'll manage.
Yeah, we'll see by the end of the semester.
I'll do all of my schoolwork. They do it again. But at least I just be out of the way. So I'll eventually acclimate back to the.
So 2 weeks from now, I think I'll get home. 3 weeks from now, is that like easy something over there? Yeah, 3 weeks from now.
No, part of your guys.
That's good.
Yeah, that's what meetings are like. Minus the
Oh, yeah.
Yeah, so it's something like it's fun. Right? It's important, it's fun.
I'm hooked. That's how I use word box.
I don't know.
Oh, geez.
I think Josh did that.
See, you're like already doing the right things. It's all
What is this?
That wasn't totally my idea.
it's not the flag, right? Alright, let's think about this logic. How it lasts a little bit. Alright, there we go. Alright, let's look at that. Look, there's a paragraph, there's a paragraph, there's a paragraph, there's a paragraph, what is each paragraph ended with?
These are things that we got.
I gotta find Simon.
Simon!
No.
Kind of the same. I was up until like 5:30 trying to get things done last night.
I was just like, I was doing good work, so like I was kind of doing good work for a while, and then some kid, Jonathan James, so I built my own.
What command you use? Can you pull up the list of challenges?
I was trying to see if crypto work done.
Install function,
Especially since I haven't really installed.
Are these supposed to he just messaged us.
First follow your president at 5:30 because I was just so out of it that I was like, I'm about to pull a Sean and firewall myself out of it.
Alright guys,
But at least I didn't. Thank God I became able to see the same.
When it says another one here, is it supposed to mean this is the same image and there's another one in it, or is that supposed to be a different link?
And they don't script.
So those are both the same thing. That's not. It's supposed to be two in one. For the images, is it supposed to be two flags in the one image? They're the same link.
One of them I'm pretty sure works.
Okay, so that's links. Okay. Just making sure.
This man is still stuck on this.
No, I got it.
Figure that out so I can test. I'm pretty sure it works. And then the other one is
too
like
hard and like what any different like layer board does.
Alright, let's
Oh, I gotta tell Joel that.
That's alright, it happens to the best of us. There was one of them where we had a text file, and you open it, and like, scrolling. So we had a whole bunch of stuff, like 100 lines, but then on line like 400, the flag was there, so you had to scroll through all that blank space.
Yeah.
A lot of people didn't get that one.
You don't notice.
They were upset.
Yeah, if you're on Daniel,
Yeah, because then you see the line like this.
yeah, it's like, oh, they're still going. Hold on a second.
Those shouldn't be there.
Yeah.
It's really funny. You can see like the subtitles.
No, that's fine. So, like, you know what you're doing. So, like, you know it's somewhere in there. So, just search, generic searching in like speed. So, the most common way you use grep is by passing something to it. The way you pass something to it, you just pipe it. And then grep you pass it on. So, you're searching for yeah, so in this case, you're searching for, like, literally just type out the string you want to search. Oh. So, like, in this case, you just type, like, in this case, the flag is in RC3. Yeah. So you deal space. Yeah, the first. Oh. Oh my God. You know the guy's nice. Dragon drop the file. No, so you got it on your VM, drag it down. I was like, download I've seen issues where actually you drag and drop something to VM. But yeah, it's strings.
Hey guys, just real quick. Sean Newman is not the president of RC3. As much as y'all like to think so. He's Sean's son.
There's always next.
Yeah, so Newman, you look so president for president. Oh yeah. You sounded more presidential every day. So my version dropped. Go fast. Is that what happens? No, your immersion can turn into a light. Yeah.
Your major taps into no, that's like oh, but you're thinking of you don't yeah, I don't know if they still do that relates a lot better. Oh, I'll have to get back into